Okay, so this answer is called the pitch, or this question is called the pitch. And what we have is we have a pitcher. He throws a 90-mile-an-hour fastball at 6.25 feet above home plate. And it is perfectly horizontal. The ball flies 55 feet before reaching the catcher's mitt. Okay, so first off, we need to convert. I said things in miles per hour. That's not okay for physics. We have to go to SI units. And in physics, the SI units for velocity is meters per second. And for distance, it would be meters. So we got to leave miles per hour and we got to leave feet. Okay, so the conversion factor, if you got 90 miles an hour, I know that there is 1609 meters for every 1 mile. So now I got out of miles. So now we got meters per hour. I can't have that. I need meters per second. So I'm going to put what we want on bottom, which there's 3,600 seconds for every 1 hour. Okay, and then that gives us velocity in the x direction. So I'll put that over here. I'll put that. So my v in the x direction is going to equal 40.23 meters per second. Okay. Also, we have to convert our 55 feet. So we're going to do the same thing with that. And we got our 55 feet. And we want meters. So I know for every foot is 0.3048 meters over 1 foot. Put what we don't want on the bottom. We will put what we want on the top. And so now I'm getting our distance in the x direction is 16.76 meters. Okay, so now the thing that links the x and y component is time. So that's the first thing we need to do. We have to figure out how long the ball was in the air. Okay, so we're going to go to our kinematic equations. I don't really know what the final velocity in the x direction was, so I'm not going to use this. I'm looking for time, so this equation doesn't help me, but this one does. Okay, so let's trim it up because we don't need all these variables. For example, this x naught, well, we're just going to say it started from 0. We're going to say this is 0. Why not? Make your life easy. So that goes away. We know the initial velocity in the x direction, but I also said there was no air resistance. So that means there's no force, so it's no acceleration. So in the x direction, it's going to leave at that speed and it's going to maintain that speed. All right, so now we got delta x equals v naught x times t, and rearrange this. We know the distance, we know v naught, so we're just going to say delta x divided by v naught x, that equals t. And that I'm coming up with a time of 0.417 seconds. Perfect. Okay, so the time is the link. And now we need to figure out the y component. How far did the thing drop? Okay, so this doesn't have time in it, so I can't use that. This has time in it, but I don't know. I'm not looking for the final y velocity. We can use that later. So I want to use this equation. We're going to say that it started off at 0. Might as well make your life easy. We know that the velocity in the y direction was 0. So that boils this equation down to delta y equals negative 1/2 gt squared, where g equals 9.81 meters per second squared. Okay, and so we're going to rearrange this equation, and we're going to solve for delta y. So I came up with, for delta y, I got delta y is negative delta y was negative 0.851 meters, which translates to feet in negative 2.79 feet. Now the ball started off above the plate by 6.25, so we're just going to take that 6.25 and subtract the drop, the 2.79, and we're going to get a distance above the plate of 3.46 feet. All right, and this would be a strike. Okay, so for the second part, we need to figure out the velocity in the y direction. So this one I like this for that. Okay, so we know it started off at 0 meters per second in the y direction, but we have gravity and we have the time. So I can just plug and chug this guy, and I can say Vy equals negative gt. All right, and so I'm coming up with a velocity in the y direction, a final velocity in the y direction of negative 4.09 meters per second. Now, finally, what we have to do is we have to find the angle at which it crossed the plate. So what you're going to do is you're going to take the tangent inverse of the y component, the v in the y direction, the velocity in the y direction, and then the velocity in the x direction. Put y on top and x on the bottom always. All right. And so you're going to make sure you're not in radians, make sure you're in degrees. And I'm coming up with negative 5.81 degrees. And so this ball essentially went below the positive x-axis by negative 0.51 degrees. I hope this helps.